idea here is that a reflection is guaranteed to be an isometry. And let's remind ourselves what an isometry is again. What is an isometry? Oh, good. I'm glad we're covering this. Again. Yeah, what is it, buddy? Yeah, exactly. It's after the image has been isometry. This says same shape and same size. Same shape, same size. So now we know a reflection is considered to be an isometry. And a reflection has what's known as a line of symmetry.
What's that say?
Same shape.
You're missing me on there, buddy.
Where? Oh, thank you. I was getting there. So, two things about a reflection, right? A reflection is an isometry, and every reflection has what's known as a line of symmetry. And it has at least one lines of symmetry. Some could have more. So we're going to talk about that in my next little example here. So the idea to take away from the first one here that we've been talking about, a reflection is an isometry, which means it has the same shape, and a reflection has a line of symmetry, or it has at least one. So here's an example. Let's draw three figures, A, B, and C. A, B, and C. In figure A, let's draw a kite. Remember, a kite has two pairs of congruent sides, but they're not. But the opposite ones are not congruent, right? Opposite sides are not congruent. Only consecutive ones for the top and the bottom. All right, go ahead and draw in where you think the line of symmetry happens to be on a kite. Adrian, where's the line of symmetry that you came up with? Yeah, this line of symmetry happens to be right down the middle, right? So this is my line of symmetry. This is my reflection point. So if I was looking at each part here, right, it's the same distance on either side for the line of symmetry. There's my line of symmetry. Okay? All right, let's take in part B, let's draw a rectangle. Draw a vertical rectangle. Okay, draw in the lines or line of symmetry. See how many you can find. Now this is a rectangle, not a square. Okay, Ricardo, give me one of them. Ooh, he says from one corner to the other. Is that actually a line of symmetry? No, it's not, because if you reflect it, so as an example, right? If I find this distance from here to here, I would have to go the same distance out, and that point would need to be off that line there. So in a rectangle, a diagonal is not a line of symmetry, even though a lot of people think it is. Can someone give me another one? Yeah. Yeah, right down the middle is one of them, but there is another. Yes, Jordan. Yeah, right down the middle on the side. So this one happens to have two lines of symmetries. So a kite has one, a rectangle has two. What about a square? Let's do square here. Is that a square? Did I count right? 1, 2, 3, 4, 5. 1, 2, 3, 4. Oh, let's do 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 5. All right, here we go. Michelle, give me one of the line of symmetries. What's that? Yeah, the diagonals? Yes, in this case, the diagonals do act as a line of symmetry, because if I take a point, I reflect it on the other side, it acts as that. Where's the other one? Down the middle, yep. And the other middle. And then this diagonal that I kind of drew earlier, right? Man, how many is this? Let's see here. This is 1. This is 2. This is 3. And then this is 4. So this one has 4. So that one has 4 lines of symmetry. All right. Let's talk about a rotation. A rotation is also an isometry. So what's isometry again mean? Yeah, so when you rotate something, it turns out that it's an isometry because it stays the same shape and the same angles are preserved and the distance is preserved. It's just in a different spot. So a rotation is an isometry, and it has two things that are important. It has a center of rotation. Also. That's that dyslexia of mine coming in. There you go. It has a center of rotation, and it has an angle of rotation. And we're going to talk about these two things. Yeah, right over there? That's okay. A center of rotation and an angle of rotation. So a rotation is an isometry. It has two parts, a center and an angle of rotation. And here's an example that we're going to quickly do. So draw yourself a little flag here. So there's a little flag. And then I'm going to put the center of rotation below the bottom of the flag. I'm going to draw a little dashed line. And then I'm going to draw a horizontal dashed line. Yeah, a little flag. So if this is my pre-image over here, and this would be my image, the angle of rotation is right here. That's my angle of rotation. And then this is my center of rotation here. And that would be, how would you describe that rotation? 90 degrees, which way? That would be a 90 degree, let's use clockwise or counterclockwise. Which one would it be? 90 degrees clockwise, right? Because my pre-image is over here and my image is down below, and I moved to the right, that would be clockwise. And notice that that flag is still the same shape, same size, so therefore it's an isometry because now we know rotations are isometries. Okay, we're going to do two demonstrations of that with our compass up next. Any questions before I change screens here? Okay, last idea. This idea of rotational symmetry. So if I draw a box here, just as an example, okay? I draw a box. And I highlight one corner of that box. It's a terrible looking box, but yeah. So this is 0 degrees rotated. If I rotate that box 45 degrees, it would look something like this, right? You guys agree with that? And then the side would be over here, right? But what happens if I would rotate it 90 degrees? What would I get? The side line would be over here, right? So that means that a square has a rotational symmetry of 90 degrees. How far do you have to rotate the square in order to get it back to the original image that you started with? Well, no. No. 90. I only have to go 90 before.
They're all the same size.
Yeah. It's still an isometry, right? I'm just showing you where it's going, right? This and this are still the same, right? So this has a 90-degree rotational symmetry, and you'll play with some of those figures tonight. Okay, there you go, you guys.